A dot plot is a diagram that shows the frequency of data on a number line. Dot plots are also called line plots. This section is about how to, or at least some of the ways, to visually represent data instead of just having them listed out as a series of numbers. One of those ways is a dot plot, and when data is written as a dot plot, the gaps and clusters of data become more apparent. So you can see an example as that dot plot is that the dots, when done clearly, when done with neatness, that the dots kind of create a sort of a bar graph, and the number of dots stacked on top of each other tell you where the clusters of data lie in a particular data set. So when you make a dot plot or a line plot, if it's called a line plot, you're going to write the data in order from least to greatest. We're going to draw a number line that starts at least data point and ends at the greatest data point. If you start a little lower or a little higher than those, that's okay, as long as you can fit all of the data on the number line. Choose an appropriate scale. That means what do you want to go by on your intervals. Now, a common way to figure this out is to take the highest number, so whatever the highest data is, and divide that by 10, and then round to something that's easy to count by. Like, for example, let's say the highest number was 45 on a particular data set. If you take 45 divided by 10, you get 4.5, and that's really close to 5, so maybe you want each interval and count by 5s. That's not a 100% rule that you have to follow. It's more of a guideline to help you choose an appropriate scale. Plot the dots on the number line and stack the points when there is more than one data point with the same number. And then, if appropriate, include a label for the number line and a title for the dot plot. So let's do this one. This is represent the data as a dot plot. So we've got data that's ranging from 9 to 15. There's several 15s actually. So the highest number being 15. An appropriate scale on this one, if you take 15 divided by 10, that would be 1.5. So you can round that to either 1s or 2s. I think I'm going to go by 1s this time because it actually starts at a low of 9. So from 9 to 15, counting from 9 to 15 by 1s is not going to be a large issue. So I think we can handle that. So I'm going to draw a number line. And on my number line, I'm going to start at least as low as 9. And you can start at 8 or 7 if you wanted to, but make sure it's at least as low as 9. And go 10, 11, 12, 13, 14, 15. And I got a little extra room there, so I'll throw a 16 in there as well. I don't have to put a 16, but since I had room on my line, I'll just put a 16 in there. And then we're going to put little dots to represent each number on the number line. So 11, we'll put a dot above the 11. I'm going to make my dots about the same size as best as I can do. We'll have a dot above the 12. We'll have a dot above the 14. One above 15. And then we have another 12. So now I'm going to start stacking dots. So I'll stack above the 12. 13, well, that's the first 13 I have. And then one above 15, and so on until I've done all of the points. And you can see there I've completed the dot plot, and you can see there's a huge cluster at 15, so there's a lot of dots above the 15, and then there's no dots above the 10, so there's a cluster towards the higher end of 15 in this particular dot plot. This data did not have a title. We don't know what it represents, so giving it a title would not be appropriate in this case. Real-world example 2 is make a dot plot with a scaled number line. The table shows internet users of Middle East countries as a percentage of their total population. Represent the data as a dot plot. So as you notice, that it's the internet users' percent of population, and it's been rounded to the nearest tenth in this case. And the numbers range from a low of 22.6 for Yemen at the very bottom to a high of, at the top, Bahrain of 96.4%. And the likelihood that there is more than one number that's exactly the same is not very good. So in this case, it is more appropriate to use what's called a scaled number line, is that we're going to do groups of percentages, and we're going to stack those dots as groups of percentages. So we'll start out by just still drawing the number line. The lowest number, again, was that Yemen at the bottom at 22.6. So instead of going by a certain specific number, what I'm going to do is I'm going to have my first little mark there represent all values in the 20s. In other words, from 20% to 29.9%. And then the second interval will represent all of those percentages in the 30s, from 30% to 39.9%. And so on. Represent all from the 40s, from 40% to 49.9%. Until finally you see that I have my last interval from 90% to 99.9%. I wouldn't want to go any further than that because there's no such thing in this case that would be over 100%. So Bahrain is at 96.4, and that falls between 90 to 99.9, so I'll place a dot there for Bahrain. Iran's at 57.2%, and that's between 50 and 59.9. Iraq's at 33%, so that's in the 30s, down here towards the left side of the number line. Israel at 74.7%, so I'll put that into the 70s, and so on. And when I finish my dot plot with the scaled number line, you can see that it looks about like this. This data does have a real-life meaning. It is the internet users of Middle East countries. So this one can be given a title, so we'll just title it that, Internet Users of Middle East Countries. And the data is represented as percentages of the population, so I'll put that as the title of the bottom of it, percentage of population. And that is a dot plot with a scaled number line. Another type of visual representation are bar graphs or histograms. A bar graph is something you're probably familiar with. Compares categories of data with bars representing the frequencies. Bar graphs are used when the data is discrete, and what that means is that the data belongs in specific categories and there are no in-between values. When there's no in-between values, there should be a space between the bars. That is slightly different from a histogram, which will be shown later in this section, where there is no space in between bars. So example 3, make a bar graph to display the data gathered from a student survey about their favorite sports. You can see in the frequency table over there how many students like basketball, football, soccer, and baseball. So we should have a bar that represents each of those 4 sports. We'll have a bar that represents basketball. So down at the bottom, I'm going to write basketball to represent that bar. Then one for football. Notice that they're not going to touch each other. And then, of course, one for soccer and one for baseball. We need an appropriate interval for this one. And again, the largest number is 25. So if you take 25 divided by 10, that's 2.5. And since the lowest number is 15, I think going by 5s would be fine on this one. I suppose you could go by 2s if you wanted to round your 2.5 down to 2 or even to 3. But I think 5s would probably be easier to count by. So we'll go 5, 10, 15, 20, 25. It doesn't have to be 5s. That's just something easier to do. And then for basketball, 15, like basketball. So I'll draw a bar that goes up to the 15. And I'll color that one in. Again, it's not necessary. Sometimes you don't see colored in bars, but it does make it nice and pretty when you do it that way. Football goes up to 25. Soccer goes up to 18. Now that's half between 15 and 20, a little over halfway. So my bar is going to go a little over halfway past 15 and up to 20. And then baseball up to 21. So that is slightly past 20. And then I will quickly color these in. And through the magic of editing, you can see that it's already colored in. And I have also titled it Students' Favorite Sport at the top, and that is an appropriate title.